All right, in this example, what we're trying to do is write the polynomial function in polynomial standard form that has the given zeros here. And one of the things we talked about in class is that if you have a zero that has an I in it, that implies that it has a square root of -1 in it. And if there's a positive, then there also needs to be a negative. Or if there's a zero that is like 3 minus 2i, then we also need the conjugate of it as is another zero. Okay, so if I give you that 3 minus 2i is a zero, then x equals 3 plus 2i is also a zero. Okay, and this is obviously example 2 from the note sheet for 2.5. Okay, so what we're going to do is set this up as a polynomial function in factored form. So we'll write f of x is equal to x minus 5 times x minus 3 minus 2i and x minus 3 plus 2i. And that is subtraction in both of them. In fact, anytime we take a zero, we use subtraction. So here we had x equals 5, and when we turn it into a factor, we do x minus 5. If this was -5, we would do x minus a -5, which would be x plus 5. So every time we take a zero and put it into a factor, we subtract it. Sometimes we just do the simplification quickly, so it looks like we're just doing the opposite sign. But anyway, so this is what we end up with. And it looks kind of ugly, but the first thing I'm going to do is distribute the negative through here and here. So this will be f of x is equal to x minus 5 times x minus 3 plus 2i times x minus 3 minus 2i. Okay? Now, what we want to do is multiply any expressions with I in them first. Okay, so we'll multiply those out, and then we'll multiply it by the expression here. Okay, in fact, in this example, just to save time, because I'm sure that you guys can do it, we will just multiply these two together so I can show you how that works, and then we'll just leave the answer like that. Okay? So let's multiply these two expressions here together. I'm going to use the box or the grid method. Okay, and the way that that works is you make a grid, and we'll make it a 3 by 3 because each expression has 3 terms in it. And across the top, we'll put x, -3, 2i, and across the left, or down the left-hand side here, I will put x, -3, and -2i. And then I'm going to multiply row by column. Okay, so we'll do the first row here is going to be x times x, which is x squared. -3 times x, that's minus 3x. X times 2i, that's 2ix. -3 times x, that's -3x. -3 times -3, that's positive 9. -3 times 2, that's -6i. We have -2i times x, that's -2ix. -2 times -3, that's positive 6, don't forget the i. And then the last thing here is -2i times positive 2i. That's going to be -4i squared. I squared is the same as -1, so it's like saying -4 times -1, which is actually positive 4. Okay. From here then, we're going to combine all the like terms that are in the grid. Okay, so we can combine a couple that are convenient, so -2ix and positive 2ix, those will cancel out. 6i, -6i, those will cancel out, or I should say sum to 0. Okay. And then we have this -3x and -3x, which would be minus 6x. And so we can write that into the polynomial now. So we'll leave this x minus 5 alone. So I get this f of x is equal to x minus 5 times, and then we'll write down what we have here. So x squared minus 6x minus, 9 plus 4, which is 13, so plus 13. Okay? And so then from there, it's just a matter of distributing the x minus 5 to the x squared minus 6x plus 13. And I guess we can just do that very quickly here. So go x times everything and then -5 times everything. So f of x equals x cubed minus 6x squared. 13 times x is 13x. -5 times x squared, that's minus 5x squared. -5 times -6, that's positive 30. and negative 5 times 13, that's negative 50 plus 15, so negative 65. Okay. All right, and then combine like terms. So f of x equals x cubed minus 6x squared minus 5x squared. This is the minus 11x squared, 13x, and then 30 minus 65 is negative 35. Okay, and that's it.